let's dive into another questions. So hey everyone, welcome back to the channel, and today we are diving into an interesting coding problem. So this is the questions 299 count the number of powerful integers. So we have to find the number of powerful integers, right? And will we use Java? So this is one of the those problems that tests your understanding of number construction, digit restrictions and recursion. So let's grab your favorite drink and let's break it down. Okay, so we have given three parts of this problem. As you can see, let's go with the statement first. So we have given, you are given three integers, starts, finish and limit. You are also given zero index string s representing positive integers. So a positive integer x is called powerful if it ends with s. In other words, s is a suffix of x. Each digit in x is at most limit. We have to return the total number of powerful integers in the range start to finish. A string x is a suffix of a string y if and only if x is a substring of y that starts from some index including 0 in y and extends to the index length minus 1 y length dot y length minus 1. For example, 25 is a suffix of 5125 where 512 is not, right? So the problem saying that we have given three parts, start, finish and a limit. We are also given a string s which represents suffix. Okay, simple term. So in the simple term for this problem, what we can say, we have given three values, that is a start, finish and a limit, and we also given a string s which represents suffix. So our goal is to find how many integers in the range from start to finish, right? And every digit in the number is less than equal to limits, right? So let's look at some quick examples, right? So let's understand, we have given start at 1, finish is 6000 and limit is 4, s is 1 to 4. So as you can see, we have given the output, right? And so the valid integers can be, right, integers can be 1 to 4, 1124, 2124, 3124 and 4124, right? And if you call for the invalid one, so invalid one will be 5124 because it has 4 digit greater than 4, right? So pretty cool, right? And let's go with the step by step understanding. Okay, you pause this video, go through the examples and see why 5124 is not a powerful integer, because the first 5 which is greater than 4, right? And it can't be shown that there are only 5 powerful integers in this range, right? So all of these values, as you can see, 124, 1124, 2124, these are less than equal to 4. But if you go for the 5124, it is not powerful because 5 is greater than 4, right? And similarly, you go through all the examples, so you will have clear understanding of this. So I'll try to cover step by step, you can say, problem, right? I'll keep it here, this statement, right? So if you need, you can pause and you can go for the statement. So first of all, what we will do, what is the steps we are going to do? So I'll put it here. So as you can do, I have added some to-dos and then I have implemented, right? Let's go with one by one. So first of all, convert start and finish to string, pad them with the leading 0 so they are the same length, right? So convert the string and pad with the 0 to match the length, right? So to do that, we have already given all in the long and string in the s. So what we will do, long dot to string will do, and we'll convert all in the low and high will convert into the string. Now we'll have the length n, we'll go with the high dot length, and so we have low, right? And low, what we will do, we'll do a string dot format and we'll pass this value and we'll replace all the this with the 0, right? So first, what is the purpose of doing this? Because we want to convert start and finish to a string, right? And we will pad them with the leading 0, so they are the same length. Okay, so that's done for the first step. Now what we will do, we will determine how many digits are here. How many digits are here? Let me keep it down. We can put it right down. Okay, leave it. So what we will do, we will determine how many digits are before the suffix s, and for that we have to do n dot s dot length. We will get the pre-length, right? So what we are doing here, we will split the numbers into two parts, right? And we will have a prefix that is called digits we can choose freely with the constants, and suffix fixed digit from s. And we will use depth first search to explore all possible valid prefix, and for each digit, right, what we will do, we stay within the bounds using the flags limit low, limit high, and as you can see, we have here, right, low and high, and we will pass these things. Okay, so first of all, in these four steps, what is the we have, you can see here. So the first step, what we will do, we will convert start and finish to strings, and we'll pad them with the leading 0, and so they are the same length, right, with the same length. And in the second, what we will do, we will split the numbers into two parts, prefix and suffix. So prefix will contain the digits we can choose freely, and suffix is a fixed digit from s, right? And then we will find the pre-length. Okay, and the step 3, we will do you can say DFS, and then for that you can use memorization also, and we will optimize this code. And so we will use in the step 3, we will use the depth first search, and we'll explore all the possible valid prefixes. And in the last, while studying recursive DFS search, right, we will stay within the bounds using the flags limit low and limit high, and we'll make sure that every digit is less than equal to limits, right? And so I think let's go with this. Okay, so we have this DFS, right, method. As you can see here, we will have memo long and these things we have. So we'll create this DFS method, right? This DFS method is here, limit low, limit high, that we were talking about. We have low, high, and limit, everything will be here. Now we'll create a base case where we'll check if we reach at the end, we'll count as a one valid number. Once we will done at low dot length, we'll have 1. If both limit is relaxed and the value is cast, we will return the memorized result. So we'll take not limit and not limit high, and memo at I is not -1. Then we have already calculated value, we will return it. We will cast value, we will return. Otherwise we'll have result, we have low and high will have. So we'll set the value 0 and 9 as a default. If it is anything else is there, then we'll find the length. If I is less than length, then we'll try all the digits is less than equal to limit in the prefix part, and we'll find digit at low, and digit if the digit is less than equal to value, we'll do math dot mean, and then we'll find the value, right? So like this, what we have to do, we have to go one by one, and we have to find this data. Okay, and so it will keep moving from low to high digits. We one by one digits we will try till the limit exhausted, and we will have our result in this method, result in this loop updated. In the else condition, we'll ensure that limit is not exhausting, and then we'll return this value. Finally we'll store the result in the memo if no result is there. Okay, so I'll put in this comment box this solution. And that's all for today. Thank you guys, thank you for watching this video.